Hello everyone, welcome to our video. I am Ganesh Mahato and joining me is Bibek Agrahari, and today we'll be breaking down a very interesting topic, and the topic is beam search algorithm. So we have prepared this video as a part of our AAT submission, but also we made it simple and understandable for anyone who wants to learn the topic in a simple way. So without wasting time, let's go start the topic.
So hello everyone, it's me Bibek. Before jumping in, a quick sort out. This entire explanation is based on the content we prepare from our presentation. Let's begin with the basics.
So we'll go for a small introduction. So first, we have to understand what problem does beam search actually solves in AI, especially in NLP. Okay, so in NLP, the system often has to choose the best sequence of words or action from use search space. So checking every possibility is very slow and almost impossible. So beam search algorithm, what does it do? It helps by keeping only the top k best path at the every steps. This makes the search fast, efficient, and still quite accurate. So Bibek will explain the what is beam search.
So what is beam search? In simple terms, a beam search is a heuristic search algorithm. Now, what does that mean? It means that the algorithm does not explore everything like exhaustive search, and it doesn't blindly pick the best immediate choice like a greedy search. Instead, it keeps multiple promising paths, scores them, and continues only with the best few. This balance makes beam search both smart and practical. Now, Ganesh will explain how beam search algorithm works in a step by step.
Thank you, Vivek. I'll explain in this page of PPT how beam search works step by step. So, at first, it being step number 1, start at the root node. This is your starting point. So, after at the initial stage, we have to start from a point from where it is starting. You have to choose a point. Then in second step, generate successors. So from the current node, generate all the possible next steps. So find out how many steps can be steps are possible from the initial stage. So then we'll go to step 3. In step 3, what does it happens? We have to evaluate using heuristic score. So in this step, each part gets a score based on how promising it is. So after that comes step 4, that is beam with pruning. So in this step, we keep only the top W nodes. That is, this is the most important part, and it removes weak part is early. It removes all the parts which is not required by which it is which is out of the k value. So we'll go to next, that is step 5. So in step 5, what we have to repeat the process until we reach the goal. We have to, and that's the entire logic of beam search. Move ahead with only the best option. This is how beam search works. Actually, you can see in the next page how beam like there is a search tree. B is equals 3. Okay, then there are 2 steps we can go ahead. That is this left side and right side. So in this way only we have to find which is the low cost part, and we have to move accordingly by choosing only by choosing the k value. So I'll request Bibek to explain with a mathematical logic with an example, so that it can be better and more easy to understand our viewer how it works and how we can use beam search algorithm. So I'll request Bibek go ahead and show how it works, how beam search algorithm works with a example, so that it can be easy and better to understand for our viewer.
Thank you, Ganesh. Now we'll be discussing what beam search algorithm. Beam search algorithm. This is the statement. So beam search algorithm take cares related to what? It takes care related to the space complexity, that is constant, and beam width, that is beta is given. As you can see this diagram, where there is a nodes connected, every node is connected to one another, and our G is the goal state, and this is the straight line distance, that is G is the goal state from A to G, that is 40, from B to G 32, and C to G 25, and so on. So now we'll select one node, that is A. Either it goes to B, either it goes to C, or either it goes to D. So we know the heuristic value of this node. B we have 32, C we have 25, and D we have 35. So based on these three value, we'll make a sorting value. So what kind of sorting value is that? First it comes to A, C, B, D. So A is already a node, that is a first node. This is the sorting. Now C also goes because C has the minimum heuristic value. So again, those value which is minimum will again make the node from C to D, C to F, and C to E. So we'll add this value, that is 35, 17, and 19. So based on this three node, that is D, F, E, we'll put on the sorting F, E, F, E, because F has a minimum heuristic value as compared to D and E. So if you take beta equal to 2, that is a beam width, and N equal to 3, so that is C, B, and D. If you decide this 3 node, if the beta equal to 2, that means we have to select C and B only, not the D. So let me change the color of that, that is C and B, which is equal to 3. Sorry, it's not 3, it's 2, because we have selected 2 nodes only, whatever the beam width has given. So this is the space complexity, that is B to the power D, and next one is also a B to the power D space complexity. So beta equal to 2 and N equal to, if there is a 3 node, we'll only select C or B based on the minimum heuristic value. So select the minimum heuristic value.
So thank you, Vivek. Now we'll go on for application. So we should also know application of beam search in AI and NLP, because if we'll know how it works, but we don't know where it is used, then it is so difficult for us. So we should also know what are the application of beam search algorithm. So beam search algorithm is everywhere in modern AI. Here are few real example I'll suggest. I'll suggest means I know, which I can share with you. So first of all is machine translation, because in machine translation it helps to build natural looking sentences. So and another one is speech recognition. It in speech recognition it picks the most probable sequence of words from noisy audio. Okay, so the next one is chatbots and text summarization. So in this chatbot and next generation, it helps to generate meaningful and coherent responses. So most encoded decoded models including LSTM and transformers use beam search to generate sequences. So Bibek, I'll request Bibek to go for trade-offs and limitations.
So let's understand trade-off and limitation. Beam search is a powerful but not perfect. Here are some important limitations. Beam width affect performance. Bigger width equal to better quality but more memory and slower. No guarantee of the absolute best solution because we prune parts early. The best part might get removed. Needs tuning. Beam width and other parameter must match the task. So basically, it's a great algorithm, but it requires careful tuning. Now Ganesh will explain the real world impact on the beam search algorithm.
Thank you, Vivek. So we should also know what are the impacts of beam search algorithm on real world. Because we should also be aware all the things, good things, bad things, how it is useful or not useful. So I'll be for that reason I'll be explaining real world impacts. What are the real world impacts are there on beam search algorithm? So beam search algorithm actually powers many tools we all use daily. So it basically beam search algorithm powers all the tools that you use in our daily life. That is Google Translate, voice assistants like Siri we use in iPhone. All of you are common in youths nowadays. They are almost using iPhone. Like Google Assistants for Android users and modern language models. These all allows complex model to run efficiently without demanding huge resources. So yeah, beam search plays a huge role in making AI usable in real world. So beam search is really a big and great thing to in this modern or you say or AI world. So I'll request Viva to summarize this.
So at last, I would like to say that to wrap it up, beam search helps AI find good solution without checking everything. It's a balance between speed, memory, and accuracy, and it is one of the key algorithm behind major NLP breakthrough.
So I like to conclude. I like to thank you all. Thank you so much for watching. We hope this explanation helped you to understand beam search in a simple way. If you have any question, just drop a comment below. Vivek, you wanna say anything?
Yeah, and don't forget to like, share, and subscribe. We'll see you in the next video. Thank you.
Okay, guys. See you soon in the next video. We are happy to share our knowledge with you. Thank you so much.